Hey guys, thanks for stopping by to check out this quickie. In this video, I'll be showing you the basics of making a fully procedural lightning effect. I won't go into any of the particle effects or, I mean, particle systems or anything of it. I'll just give you the basics of creating this lightning material. Okay, so let's see. I can procedurally change the width. Okay, that's more like a fire column than a lightning bolt, so probably best to keep it thin. The sharpness can be adjusted if you want like more crisp or sharp bolts. I like semi-crisp. I mean, not too sharp. Adjust the color temperature. That's sort of a fire. The good middle ground is about 6,000 or so. Okay, so let's break this down. The heart of this system is the generated band material function. We've got scalar parameters for width, sharpness, a direction switch. Now, the vertical direction, it works fine and looks like a great little lightning bolt. I'll show you what it looks like if you switch it back to false, or I guess the default setting, a little later at the end of the video. Now it's the UVs, of course, where everything really is important. So, I basically recreated this one system. I used a panner. For the first panner, as you can see, speed x5.5, and 1. More speed, more rapidly the variation changes. I used append vector to plug in a 0 to make it into a 3 vector, which I then plugged into a noise node. This is where the procedural effect really comes into its own. For the top vector, I guess, for the U in this UV adjustment, for the noise, scale is 2, just play around with the settings. I used fast gradient because looking for some efficiency here. It's not too important that we worry about quality too much. Turbulence, very important. I liked about 6 levels or so for this one. Now your output min and max, these are very important. You want them very small because big numbers can have a very big effect when it comes to the UV coordinates. We're talking about a value between 0 and 1, so we don't want to adjust those too much. So the min for the first noise is set to negative 0.1, and the max is set to 0.1, and the default level scale. I then masked the noise so we just got the R value, so it's just a single channel. Then for the second, for the duplicate, the other noise, just a little bit of panning in the X, same old append vector, with the constant of 0 for the blue channel. Then for the other noise, I made it scale a little higher, or smaller, I guess. Same fast gradient, a little bit less levels, and a slightly smaller output min and max. You don't want them to be exactly the same, or else things will get a little funny. So then I appended those two vectors together. That gives us a 2 vector noise. I then add that to a basic texture coordinate, and I plug that into the input coordinates of the generator band, and that produces this beautiful effect. Like, let's just break the links on that and let it compile real quick. And without those noises, it's just a glowing beam. Oops. Plug that back in. And there you go. Ah, yes. We take that generator band output, plug it directly into the opacity. We set up a lerp between 0 and our color temperature scalar value. You want to be pretty high when it comes to color temperatures. And then we take the output of that lerp and plug that into a black body node. And that gives us a nice effect. And the basics for the material: it's additive and unlit and two-sided. I mean, you don't want to have a one-sided lightning bolt, obviously. Alright, so I hope that you found this helpful, so thanks for watching.